Hello and welcome back. In our last video, we took a look at deploying a Kubernetes cluster to Equinix Metal using the Cluster API. Now, things were successful in that video in that we got a Kubernetes cluster from the Cluster API. However, if you dig a little bit deeper, or if you followed along, you may realize that that cluster doesn't really do anything. There are no workloads on it, and even worse than that, the control plane isn't even that happy. Now, why? Well, the Cluster API is opinionated on what a Kubernetes control plane looks like to a point. You still have some decisions to make once the majority of that control plane is online. And when we take a look at a cluster provisioned by the Cluster API, we'll cover this in slightly more detail. But all Cluster API clusters need a CNI implementation, a Container Networking Interface implementation. That is, we need something that is able to handle and dish out IP addresses and DNS resolution within our cluster. Now for DNS, we're going to use Core DNS because that's what the Kubernetes project recommends. However, Core DNS can't and won't be happy until there's a CNI. So we're going to take a look at how we take our cool demo from last time and turn it into something that resembles a production Kubernetes cluster. Let's have some fun. We're not going to spend too long, but we are going to have a very quick recap on where we left things. Firstly, we were using cluster control to initialize the Equinix Metal Cluster API provider into a local kind cluster. And it looks something like so. When we initialized the provider, we had to make sure that the Equinix Metal API token was available in our environment. We then used the cluster control generate command to generate a cluster YAML for a cluster on Equinix Metal. Again, this required more environment variables that configured the metro, the device type, and so forth. We then applied that cluster.yaml to our local kind cluster, where the Cluster API detected it and made some magic happen. We then used the cluster control get kubeconfig command to download a new kubeconfig that we can use to query our new Cluster API cluster. Now, as we said in the introduction, this cluster is by no means healthy. Now, we have a scheduler, a proxy, a controller manager, an API server, and etcd, which is a majority of a control plane, and they are all very healthy. We even have the cloud provider for Equinix Metal that we'll see and play with in a future video. But let's focus on these two pending pods. These are Core DNS. Now, well, you could be successful with a cluster without internal DNS, kind of. It's probably not what you're looking to do, especially not in a production cluster. But what you definitely need to have any success with a production cluster is a CNI implementation. That is what Core DNS is waiting for too. Now, we could deploy our CNI manually using Cilium install, but we want to automate this and hook in to constructs provided by the Cluster API to make this child's play. And that's what we're going to do. Let's crack open VS Code, start crunching out our YAML, and let's take a look at how we use Cluster API and GitOps to get our production cluster. Now, I've gone ahead and created the YAML for our first deployment, which is going to be Argo CD, which enables us to use GitOps with our new workload managed by Cluster API. In order to do this, we're using a custom resource definition from the Cluster API project, notably addons.cluster.xkubernetes.io. Specifically, we're deploying a Helm chart proxy. Now, this is a relatively simple manifest. We give it a name, Argo CD. No points for guessing why. We then have to tell it how to target the clusters to deploy this resource. So here we're saying select all clusters with a label Argo CD chart enabled. We then provide the chart information and values. So that is just pointing it to the Argo Helm chart, giving it a name, and telling it that we want to wait for jobs to finish, resources to be healthy, and give it a 5 minutes timeout, and create the namespace if required. So now that we've ran through that, we can say kube control apply -f Argo CD. Now it's important to note that I am not using kubeconfig equals KC. That is the kube config for our workload cluster. We are not going to touch that manually at all, except to see what's happening. Instead, we're applying this to the management cluster, which is the cluster we ran cluster control init against. For us today, that is our local kind cluster. So let's hit apply. And oh shoot, it doesn't work. Now the reason this doesn't work is if we run API resources and grep, you'll see that we have clusters, machine deployments, providers, machine sets, and so forth. And in fact, the only add-ons that we have are cluster resource sets and cluster resource sets bindings. Now, while we could use cluster resource sets, and we'll take a look at them in just a moment, the recommended way is to use the Helm add-on provider, and that requires just a little setup. So how do we turn on the Helm add-on? Well, it's as simple as running cluster control init again. We have to set our infrastructure provider to packet just like we did the first time. Only this time we can say add-ons Helm. And because I've got secrets, I'm going to run this through 1Password to pass in my Equinix Metal token. Now this is just going to reinitialize the cluster API operators and add on our new add-on. As you can see, it's not repeating itself. It already knows that Cert Manager is in our cluster along with some other controllers. And instead, it's just adding on our Helm add-on. Now we can do a kube control apply, Argo CD, and let's give that add-on a minute to become healthy. And there we go. Now we have added our Helm chart proxy to our cluster. And we can see Argo CD is ready and true. Now we've got one more thing to do. We need to make sure our cluster is labeled correctly. So let's pop open our cluster.yaml and search for kind cluster. And under metadata, we're going to add labels where we want Argo CD, and this must match what we put here. Argo CD chart enabled. Now we can reapply our cluster YAML, and cluster API will do everything from here. So let's just check back in a moment. Let's run kube control and target our workload cluster. And we can do get pods -a. Now, as we can see here, Argo CD has kind of been deployed to the cluster, but unfortunately it is pending too. This gives us a bit of a chicken and egg situation, because how can we use Argo CD to deploy our CNI if Argo CD can't really get deployed to the cluster itself? And I feel that this is something important to call out. You need to be able to break down your cluster into things that need to be updated regularly and automated, such as your developers' applications, service meshes, security, critical infrastructure, and so forth. But your CNI is a very core part of the control plane and should be treated as a cluster upgrade more than a running upgradable workload. And as such, we're going to deploy our CNI not with Argo CD, but with a cluster resource set, which is something that will only be deployed once by the cluster API. It then becomes part of your responsibility during cluster upgrades and Cilium upgrades to manage that specially. So let's prepare Cilium. Here I have a just file target for how I would normally install Cilium. Now, instead of using Helm upgrade, we're going to use Helm template. We're going to do this because it will allow us to create a single YAML artifact for deploying Cilium to a cluster. Now, there is one gotcha here. To deploy Cilium, we do need to know the public IPv4 address of our control plane node. To get that, we can query our workload cluster, saying get nodes, oh wait. And we could grab this IP address, like so. Now at this point, you might be wondering why I'm going to this effort to template it and create the YAML rather than just deploying it to the cluster. And that's because automation is key to working with the cluster API. While some of these steps I am doing manually now, getting that IP address by asking for JSON output from the kubectl command and parsing it with JQ is something you can quite easily automate via Ansible or any other tool. So we're going to stick with that automated path. Now we can just copy these commands one by one instead of using the just target so that we can see the output and move at our own pace. Okay, paste Helm repo add to add the Cilium repository. We can then copy our template command. We can then paste the template command and it spits out a whole bunch of YAML. Let's just run that again and save it to cilium.yaml. Now, it's not important what's in there. What's important is that we can deploy this to the cluster to satisfy the Argo CD dependency, get core DNS online, and have something that is fully automated. We need to take this cilium.yaml and get it into our management cluster. For that, we can create a config map, and we'll call it Cilium, obviously, which is coming from a file, cilium.yaml. Now we can look back to what we said earlier, cluster resource sets. These are the simplest way to deploy things from the management cluster to the workload cluster. So again, we're using the add-ons cluster, and the kind is cluster resource set. We give it a name and a namespace. Nothing here is going to surprise you. And we're using the same selector we used for the Helm chart proxy, only this time we're matching any cluster that requests the Cilium CNI. Meaning, really, I could set this up for any CNI and have clusters running any CNI across the board. We then just need to give it the ability to get those resources. And we're saying that ours is stored in a config map called Cilium. Now, if there's sensitive information, which may be the case for bootstrapping a new production cluster, you can also choose to use a secret. So let's apply this cluster resource set with Cilium to the management cluster. So the last thing we need to do is label our cluster, much like we did with the Argo CD deployment. So we can open our cluster, say CNI Cilium, because that's what we set in the cluster resource set. We can then apply the updates to the cluster and then set up our kubeconfig and run get pods, and we'll see the Cilium is now deploying to this cluster. Let's give that 30 seconds and check back in. Let's set up our kubeconfig one last time, hopefully. Run get pods and all. And that's looking pretty good. You can see now that our core DNS is deployed and happy. Cilium almost there, and Argo CD is now kicking away. And there we have it. We've went from cool demo to cooler demo potentially being production. Now with the cluster API, you can have a control plane to manage your clusters. Cluster API does a whole lot more, and there's more videos in this series coming, so stay tuned.